tomorrow. So this whole section or chapter, I guess, was about what? What did we do all chapter long? Try to solve equations, right? Exactly right. So if we were going to solve equations, our main goal every single time was to what?
Isolate the variable and make it positive.
Isolate the variable and make it positive. Get an answer, yes. But we want to make sure that that variable is all by itself and positive. Does not mean that my answer, which is a number, couldn't be negative, correct?
Yep.
That doesn't matter to us. So we turn to page 138. On page 138 is a bunch of problems from this chapter. Sorry, I just thought about something here. So again, we started out at the beginning with section 1 on the distributive property. Anytime that I hear the word distributive, what's that mean?
Multiplication.
Multiplication. Got to distribute it, right? Take whatever's on the outside of the parentheses and multiply it to every single part of the inside. So if there's multiple parts, doesn't matter how many parts, I got to multiply it to everything. When I do something like number 13, I got to make sure I take the negative sign with me. So I'm multiplying -5 through there. And then we got to go back and we got to think about our rules for multiplication, right? Meaning the signs of our answers. If my two numbers have the same sign, both positive or both negative, my answer is always what?
Positive.
Positive. If they're different signs,
It's negative.
negative. Doesn't matter which one's bigger or smaller, doesn't matter which one comes first. Okay? I can distribute a number or a variable. If I would have a variable out there, how do I take a variable and multiply it to another variable?
You have to
You guys have the same variable.
Put a 1 in front of it.
Yeah, but how do I show that I take A times Z? So if I have this, and I don't know if we ever really had any of these, but this could happen, right?
Would it be AZ?
Then we would just say AZ, right?
Yeah, AC.
We can always just put the letters together,
Be
and
AC
then
plus A3.
plus, but we always want to try to put the number in front, right? Okay,
So then would it be 4AZ?
so here's the question. Can I combine this and this together?
But it's like a cow and a horse, because A and Z are together. You
Exactly
can't
right.
add them together, so that's technically your answer.
This is my answer. Okay? He's getting technical. We could put the number on the backside like in 15 and 16, right? Still means the exact same thing. If we would do 17 and put -2 on the backside, we'd have to make sure that we use parentheses though, right? Because if we just wrote it as -2 on the backside, then it might look like we're trying to subtract 2. So you got to be careful on it, that. So any more on 11 through 18? All right, 19 through 22. Now we're simplifying algebraic expressions. This is where we're thinking about cows and horses again, like Trevor said. They have to be exactly the same thing in order for us to add or subtract them. So they have to be the exact same variable, and the variable has to have the exact same exponent on it. And then we really just add or subtract the what? The numbers in front. And what do we call those numbers in front?
Coefficients.
The coefficients. Exactly right. So we only add or subtract the coefficients. Before we can do all that stuff, though, we got to make sure we get rid of all parentheses. And getting rid of parentheses is why we had to do section 1. So we would distribute, and then we would combine our like terms after that. Everybody okay with all that? So, any problems with 19 through 22? Want to see any of those on the board? All right. So then sections 3 and 4 go into solving equations again. As Michael said, as Trevor said, we're getting an answer by getting our variable isolated and positive, so all by itself and positive, by using the inverse operation. So basically we're covering up the variable part and asking ourselves, how do I get rid of whatever's left over? So if it shows minus, we would add. If it shows addition or a plus, we subtract. If it shows multiplication, we divide, and so on and so forth. So, any problems with 23 through 30? Don't forget all of our rules again. We've already talked about the multiplication and division rules, but we'd have addition and subtraction rules too that we have to go back to, right? So if we're adding and the signs are different, we actually subtract and use the sign of which one?
The bigger.
The bigger one, quote unquote, right? The bigger one meaning the biggest absolute value. If the signs are the same and we're adding, we just add and use that sign. Okay? So any of those that you want to look at? Remember on number 30, example of number 30, if they would have the negative up on the R instead of the 5, it's still the exact same problem, right? So you can always move that negative from the top to the bottom. But we always said that you should always try to put it with the number and not with the variable. Okay? So any of those you want to see? We're really smart today, huh? Turn the page. So 3.5 and 3.6 are using two-step equations. 3.5, we're just solving them. 3.6, we're actually writing them and then solving them. So in 3.5, again, we're using our process to still get our variable all by itself and positive. But basically, we're going to go kind of backwards of PEMDAS, right? So I told you, you kind of think of SADMEP, because you should try to add or subtract something first. So again, I'm going to cover up that part with the variable and ask myself, how do I get rid of that number that's left alone? And then I would multiply or divide at the end. Still in these problems, we don't see too many of them in the book, but maybe on the test tomorrow, the first thing that you have to do is get rid of parentheses. The second thing you want to do is combine like terms. Bring all of your variables to the one together, okay? And then you would go and do those processes that we just talked about. So, 31 through 34. Any of those you want to see?
Can you do 33?
I can do 33. T over 3 plus 4. Equals what?
2.
Thank you. So again, as I see this, I'm going to cover up the part that has the variable, and then I'm left with plus 4, so how do I get rid of positive 4? I'm going to subtract. Whatever I do to one side, I got to do to the other side of the equation, right? To even it out, my 4's are the same number but different signs, so they cross out. What's 2 minus 4?
-2.
-2. Again, if that bothers you, take 2 seconds and write it above there. And then you can show yourself that you're going to keep change. But we get the same answer. And then t divided by 3. How do I get rid of division? Multiply. Whatever's on the bottom. And again, whatever I do to one side, I got to do the other side. Cross them off. T equals -6. Haven't said this before, but on all of these problems, should I really get one wrong?
No.
No, because why?
You can check it.
I can always put this back into the original problem. Most of you are too eager to play your stupid video games, so you won't go and check them. I'm right, aren't I? Okay. Any others on that section? How about writing them?
Yeah, I was confused.
When we write them, remember we got to think about all of our key words, right? So for addition, our words were what?
Some and altogether.
Altogether, maybe? Increase,
In
more than, plus. Okay? How about subtraction?
Subtract.
Difference, subtract.
Less than.
Less than, decrease. What's the difference between less and less than?
Less than, you have to flip them, less you don't.
Perfect, right? Multiplication,
Factor.
maybe.
No.
What's the answer to multiplication?
Product.
Product. Multiply, times, at could be used. Okay. What are ways of showing multiplication?
Dot.
Use a dot.
Put them right next to each other.
Perfect. We avoid the x probably now,
They could look like a variable.
right? Because it looks like a variable. And then words for division.
Divide.
Quotient.
Division.
Again, that one kind of runs out of words, right? How do we show division?
Fraction more.
Usually a fraction now, right? We could go old school and put the box, but it's usually a fraction more. Or we could use our what? Okay. So, again, unfortunately, when they do this, it's way easier, it seems, with their examples in 35 and 36. If you go over and look at the practice tests, 19 and 20 might be a little bit more difficult with the word ones.
Could you do 19?
Yeah, you can do 19.
Sure, we
Yeah,
can do
do
both of them.
19.
19. The quotient, okay, so everybody read it and think about what you would say. Okay?
Can I see it? See for it?
Sure.
Oh my gosh.
What number was this again?
19.
Okay, go ahead.
Wait, do you want me to like say it? Do you know it?
You said you were gonna tell me. Go ahead.
Oh, like tell you like the whole thing?
Okay, I have.
Oh, tell me what you would write down.
Can I tell you? Because I actually-
X over 8 minus 17 equals negative 15.
Yeah, he's right.
Equals what?
Negative 15.
Everybody agree?
Yeah.
Okay, so how am I gonna solve?
Plus 17.
Plus 17,
And
And
x over 8 equals 2, and then
times, right?
8 times 2. And
So
then
x would have been?
X equals 16.
16, perfect. Look at 19.
We did it.
Oh, sorry, 20.
Oh, less than?
So now we got less than, right?
So 3 minus
3x minus 5 equals 25.
Perfect. So again, when it says 3 times the number,
Minus 5.
minus 5,
equals 25.
Oh!
25. So 10,
It's not going to go 8.
Wait. X is
So what if it
10.
didn't say
Oh, no,
less?
it is.
So what if it didn't say less than it just said less?
So if it said less, then we would have done this.
Subtract 5. Or my,
So this was less than, this is less, right?
So then, the only thing that really changes is that negative, is that it's that 3x is going to be negative.
Right, so it would have turned into negative 10.
It's negative or something.
Yeah, exactly. Okay. How about 24? So this is that one where you gotta basically think about, so find a little piece of paper or something. And see if you can do number 24. So this is where you're going to have one variable kind of represent two people or two different things, right? So this is where we're going to kind of have the variable show two different things at one time. Because we never want to have two variables in one problem, right? I can never solve because, as Trevor said earlier, it'd be a cow and a horse. And we can't add or subtract cows and horses together. So try number 24 out.
Pretty sure. I might have. When I put it in, it gets the right answer.
It gets the right answer. Okay, so first things first. In one of these problems, what should we do? we should tell ourselves what we're going to make the variable. So x is going to be what?
5.
No, I put,
Nine.
You can't just make up a number. Look at, who is x?
Todd.
Todd. Fair enough. Todd is x. So, what is true about Todd and his brother?
Todd is 5 inches taller.
Todd's taller, right? So at the end, Todd has to be taller than, did they say the brother?
Yeah.
no,
It's just his brother.
Let's just go, okay.
Just do Mark or something.
Alright, brother Mark. There we go. Who?
Jaquadius.
Demetrius.
Alright, so, what's true about Todd and his brother's height?
This is 5 inches. Okay,
Todd is
so
five.
their height total is 139 inches.
So it's gotta be a total, which has to be equals, of 139, right?
Yeah.
And if we make Todd x, what are we gonna do with Todd and Mark's heights? We're gonna add them together. So how do we describe Mark's height compared to x, or Todd being x?
Plus 5.
Todd is what?
5 inches taller.
So more.
So, here's the thing. Whatever you essentially make into x, you're going to really use the opposite word for the other person. So it said that he was 5 inches taller than Mark. So when I write down Mark and I'm saying Todd is x, Mark is really what to x?
Less.
He's really 5 less than, right? So essentially, yes, we're going to come and write 2x minus 5. But do you understand why we wrote x minus 5?
Yeah.
Because Mark is 5 less than Todd. Or Todd is 5 more than. So in a sense, when you hear the word more than in that, you do the opposite of it to show the other person. So then, as Michael said, my problem really turns out to be this, and now I'm ready to solve. But this case, the solving part's not the hard part. This part's the hard part, right? Coming up with that. Okay? Now, realize, I could have wrote the exact same problem as that right there, right? Because now this represents x as being who? The brother, Mark, right? Because x plus 5 would be Todd, because he's 5 taller than him.
But if it would have said he's 5 inches shorter, would you have?
You can do it both ways, you just gotta think about who you're actually making x in the problem. So both of these are gonna be able to be done with what you just said. If it says he's shorter or if he's taller. But then the solving part should be pretty simple, right? What am I gonna do to solve?
Plus 5.
Add 5, so 2x equals,
144.
so x is equal to
72.
72. So what is 72 signify?
How tall Mark is?
How tall who is?
Todd.
How tall Todd is?
Yeah.
How tall is Mark?
Well, you take 139.
Okay, you could take 139 minus 72, or you just take 72 minus 5. So Mark is 67 inches, right? Because he's 5 less than. Todd is 5 more than. Make sense? Do those two add up to 139?
Yeah.
Okay. And then the last thing that we talked about was formulas, right? A formula, again, is a bunch of variables put together, and we can manipulate the formula for whatever variable we want. So we can do multiple problems in a formula. Our formulas that we talked about were the distance formula, D equals RT. Remember that it's all lowercase letters. And then we also talked about perimeter, which was what? All the outsides, right, added together. And then area of a rectangle was what?
How much
What side?
What's on the?
Okay, what's on the inside and what was my formula?
Base times, no, length times width.
Base times height or length times width. Those are the same thing, just different letters. The last thing that you had to remember in those, which I think most of you did, was the label.
Perimeter's just the label.
Just the label for the perimeter, and area is squared. Why is it squared?
Because you're multiplying.
Because we multiplied two things together. Exactly right. So, do you need to see 37 or 38?
No.
Okay, so those are just rectangles. All right, any questions with any of the others? All right.
Somebody got it.